Design Models folder. Open the drainage design drawing. In the drawing, we now have the networks drawn in profile views. We're going to make some changes to the network in both plan and profile. In the upper viewport, we're looking at the junction of McAllister Boulevard and Sycamore Heights. In the bottom viewport, zoom to structure MH5 as shown. In the top viewport, select the structure. The editing grips are displayed. The square grip allows you to move the structure. And the circle grip will rotate the structure. Use the square grip to move the structure to a new location. When you move a structure, the connected pipes stay connected and move with the structure. In the profile view, notice that the rim elevation of the structure remains connected to the reference surface. Move the structure back to the intersection of the alignments as shown. Now select the pipe to the right of the structure. The square grip in the middle of the pipe will enable you to move the entire pipe to a new location. The direction of the pipe remains fixed. Turn on dynamic input on the status bar. If it's not visible, use the customization button as shown. To make it visible. With dynamic input turned on, the arrow grip in the middle of the pipe allows you to change the pipe diameter or width. Dynamic input allows you to view a readout of the selected pipe size in feet. You could also type a value into the input field. Zoom to the left-hand end of the pipe and select it again. The arrow grip at the end of the pipe allows you to shorten or lengthen the pipe. You can see in the structure properties here that the connections show 3 pipes are still connected. You can use this feature to change the position of the end of the pipe within the manhole structure. The square grip at the start or end of the pipe allows you to move the point to a new location, disconnecting it from the structure and changing the pipe direction. You can reconnect a pipe to a structure by using the square grip and dragging the end point back over the structure until the connection symbol is displayed. Now pan across in the top viewport to the pond. The bottom viewport ran the profile view to show the structure at the pond. This structure is currently a manhole, but should be a head wall. Select the structure and plan. Right-click and choose Swap Part. In the Swap Part Size dialog, select one of the concrete rectangular winged head wall parts. And click OK. You can see that the part has changed in the profile view, although in plan it still shows as a circle. Select the structure and plan. Right-click and open the structure properties. On the Information tab, set the style to head wall. This shows the head wall in its true shape. You can now select the head wall and rotate it so that it is parallel with the embankment. In the profile view, we need to adjust the position of the pipe relative to the pond. Select the pipe and using the central square grip, move it up in the view. You can use the diamond grips on the end of the pipe to adjust the crown center or invert elevation of the pipe. By selecting two adjacent pipes, you can use the diamond grips to edit the ends of the two pipes to the same elevation as shown. The head wall is currently placed inside the embankment of the pond. We can adjust its position in plan so that it sits on the edge of the pond in the profile view. In the profile, you can use the arrow grip on the top of a structure to edit its top or rim elevation. Now, using the object viewer, review the position of the head wall relative to the pond. In this drawing, we have part of our pipe network shown in plan and in profile. We're going to edit the network using the pipe and structure properties and some other methods. Select pipe P7 in the plan. Right-click on it and choose Pipe Properties. You can also use pipe properties from the Pipe Network Contextual Ribbon tab. In the Pipe Properties on the Information tab, you can edit the pipe name and description, and change the pipe style in Render Material. Go to the Part Properties tab. The pipe flow direction method sets the rule that's used to determine the direction of flow in the pipe. The reference surface changes the surface used to determine the cover depth of the pipe. In the Geometry section, you can change the slope of the pipe holding either the start or the end of the pipe fixed. Change the value of pipe slope. Hold Start to -1% and click Apply. Note the updated pipe in the profile view. Change it back to -0.49% and click Apply. You can edit the pipe elevations of either end of the pipe by invert, crown, or centerline of the pipe. You can also edit the coordinates of either end of the pipe. Change the end invert elevation to 647 feet and click Apply. Then change it again to 648 feet and click Apply. The resize behavior controls which elevation remains fixed if the pipe size is changed. Set the resize behavior to crown. Now if the pipe size is changed, the crown elevation will be used for the elevation of the pipe. The hydraulic properties are only used when the pipes are analyzed, and can be used to store information about the results. Under Part Data, the Manning coefficient can record the roughness coefficient of the pipe material for flow analysis. The Hazen-Williams and Darcy-Weisbach factors are alternatives. At the bottom is the inner pipe diameter, which can be used to change the diameter of the pipe. Change the inner pipe diameter to 24 inches. And click Alley. You can see in the profile view the crown has been held fixed. Change the inner pipe diameter back to 12 inches. On the Rows tab, you can review the pipe rules that were applied to the pipe, together with their actual values. And you can check the status of the rules. Here you can see both the minimum slope and minimum cover depth rules were violated. If I were to change the slope of the pipe in the part properties so that it meets the slope rules, you can see that back in the Rules tab, the minimum slope warning has been removed. Click OK to dismiss the dialog. Now select the structure MH7. Right-click and choose Structure Properties. On the Information tab, we have the same options for changing the name and stars for the structure. On the Part Properties tab, we can change the reference surface that's used to calculate the rim elevation of the structure. You can see the structure update in the profile view if you swap the reference surface. Under Geometry, you can change the rotation and insertion coordinates of the structure. The insertion rim behavior controls how the rim elevation is calculated. Automatic surface adjustment controls whether the rim elevation is calculated automatically from the surface or is set manually. The surface adjustment of value allows you to set an offset from the calculated surface elevation, for example, to have the structure protrude above the ground. The sump behavior controls whether a structure has a sump below the pipes. For example, when the structure is a catch pit. You can set the sump method and depth here. Again, the hydraulic properties are used to provide inputs or store results from drainage analysis applications. And apart data, you can change the structure type and benching method which are used for analysis. You can change the rim to some height of the structure and set other values such as wall and floor thickness. And the structure material. Other dimensions such as frame length and width may not be populated, and the available options will vary depending on the catalog and the parts that are used. The inner structure diameter can be used to change the diameter of the manhole. Change the inner structure diameter to 96 and click Apply. Note the changes in the profile view. Set it back to 60. On the Connections tab, you can review the pipe connections to the structure. The status column displays the rule status for connected pipes. In here, you can change the elevations and slopes of the pipes. When selecting multiple pipes, you can right-click and then match the pipe elevations across the selected pipes. The Rules tab displays the structure rules that are assigned to the structure together with the actual values. The status column will display any rules that are violated. Click OK to dismiss the properties. Now select the Storm 1 network in Prospector, right-click and choose Edit Network. This will call up the network layout tools, enabling you to add to the network. On the right-hand side of the tools, you'll find the Pipe Network Vistas button. This will open tables for pipes and structures in the Panorama Viewer, which you can use for editing. Click on the button to open the vistas and then go to the Pipes tab. Here you can see pipe information in tabular form. Items not grayed out can generally be edited. The status column displays a summary of rules that are violated. Note that the inner pipe diameter cannot be edited from here. You can change the surface and edit the pipe coordinates, elevations, or slopes. Review the properties that are available. Go to the Structures tab. Again, you will see a table of the structure properties, where you can edit names, styles, the reference surface, and structure coordinates and elevations. You cannot change the structure diameters here though. Close the panorama viewer and the network layout tools. Switch the drawing back to a single viewport. We need to combine the Storm 2 network that runs along Woodside View with the Storm 1 network for analysis purposes. From Prospector, click on the Storm 2 network, right-click and choose Select. From the Pipe Network Contextual Ribbon tab, on the Modify panel, choose Merge Networks. In the Merge dialog, select Storm 2 as the network to be merged and click OK. In the Destination dialog, select Storm 1 as the destination network and click OK. In Prospector, you can see there is now only one network, Storm 1, and the two networks have been merged. Now zoom to Manhole 2 at the junction of Woodside View and McAllister Boulevard. At this location, there are in fact still two structures. Manhole 2 is from Storm 1. And there is an end structure from the Storm 2 network. In Prospector, use the Item List view for the structures. And sort the list by clicking on the name column header. Select Structure 15 from the list, which was the last structure in the Storm 2 network. Move the cursor into the model space and use the Delete key to delete the selected structure. Then select the last pipe on that run and using the end square grip drag the pipe away from the structure. And then drag it back until the connection symbol is shown. Then click to reconnect the pipe to the structure. We now need to rename the pipes and structures that were emerged from Storm 2 to continue the naming convention and numbering used in Storm 1. Looking at the pipes in the Item List view. The pipes from the Storm 2 network have been added, but the names do not match those from Storm 1. From the Modify ribbon tab on the Design panel, click on Pipe Network. Then from the Modify panel drop-down, choose Rename Parts. On the command line, it's asking for the first part to be renamed. In the Model Pants, the first stretch on the run and select it. And then pan to the last pipe on the run and select that. Press Enter. In the Renamed Parts dialog, for structures and 4 pipes have been selected. For structures, click on the Name Template button and change the name format for the structures to MH and then the space. And then add the field Next counter. Set the starting number to 12. And click OK. For pipes, set the name template to P with the space and their next counter without the brackets. Set the starting number to 11. Select Rename Existing Parts, then click OK to rename the structures and pipes. In Prospector, review the pipe and structure names. You can see that the naming is now consistent for both. In the drawing, we can see that the structure shown is using the style for a sanitary manhole when it should be a storm manhole. Select the structure, right-click and choose Select Similar to select all of these structures. Right-click again and choose Properties. In the Properties 15 structures have been selected. Change the style to Storm Sewer Manhole. You can see the style has now changed in the drawing. We're going to edit this style to draw a filled shape of the correct size for each structure. From the Tool Space Settings tab, expand Structure. The next band, Structure Styles. Select the storm sewer manhole style. Right-click and choose Edit. In the Style dialog, go to the Model tab. Here you can set how the structure is displayed in 3D. The structure, when viewed in 3D, will use the shape defined in the catalog. We can swap this to use a simplified shape by selecting Use Simple 3D Part. And then we can choose a simple 3D shape. Keep the setting to use Catalog Defined 3D Part. Go to the Plan tab. Here you can set how the structure is viewed in Plan. The current setting is to use a user-defined part. This means it's using a block in the drawing as the structure symbol. And you can set the scale of the symbol below. We want to see the structures at their true size, so we'll select Use Outer Part Boundary, which will draw the outer shape of the part as it's defined in the catalog. Enable Part Masking at the bottom of the dialog will hide the pipes inside the manhole. Now go to the Profile tab. Here we have 3 choices. Display a solid will draw the structure as a solid in the profile view, which will show the correct shape, but also show some additional modeling lines which are undesirable. Displays Boundary will show the outer boundary of the catalog part. Displays Block will allow us to substitute a block for the structure and set its scale. Using this option will not allow the structure to stretch if its depth changes, which could lead to confusion. Select Display as Boundary. On the bottom right of the page, crop structure. A profile view extents will trim structures that extend beyond the view. And Enable Part Masking will hide pipes inside the structure. Go to the Section tab. Here we have the same options for displaying intersection view. The Sliced Section option will show only the cut area of the structure if the sample line passes directly through the structure. Ensure Displays Boundary is selected. Now go to the Display tab. Here we can control the visibility of different components of the structure. In the planned view direction, we want to display the structure hatch. Set the color of the hatch to blue. Click on the hatch pattern in the component hatch display and set the type to Solid Fill. Click Apply to see the changes. Change the view direction to Profile. Turn on the structure hatch again and set the color to blue. Change the hatch pattern to Solid Fill as before. We won't see the changes for this until the viewport is active. Set the view direction to Section. And turn on the structure hatch and change the color. And set the hatch pattern to Solid Fill. Click OK to save the changes and review them in the profile view. The pipes are currently displayed as a double line. We're going to edit the pipe style to show a single line in Plan that shows the inner pipe diameter. In the Settings tab of the tool space, expand IE and then expand IE Styles. Select the double line storm style, right-click and choose Edit. In the Style dialog, go to the Information tab. Change the name to Storm. Now go to the Plan tab. For part wall sizes, we're currently using the part dimension. Wall thicknesses will be drawn to the size defined in the part. You can override this by using User Defined and setting the pipe inner and outer diameter. The pipe hatch options will control which parts are hatched to the inner walls, to the outer walls, or the walls only. If you apply a hatch, then you can align the pattern to the pipe. The pipe end line size controls how the pipe end is closed off. It can be set to draw to the inner walls, the outer walls, or use the Define to match the wall sizes. We won't be drawing end lines and plants, so we can ignore this setting. The pipe center line options control how the center line is drawn. The choices are by line weight or to specify a width. We want to show the pipe center line with the thickness that matches the inner pipe diameter. Select Specify Width and then change the size to draw to inner walls. Now go to the Display tab. In the Planned View direction, turn off Inside Pipe Walls and Pipe End Line. Turn on the pipe center line. Click Alley to see the changes. We're now going to change the profile display. Go to the Profile tab. We see similar options here to the Plan tab. Except the center line options are replaced with crossing pipe hatch options. Pipe wall sizes should be set to use part dimensions. The pipe hatch options should be set to hatch walls only. Leave the other settings on their defaults. Now go to the Section tab. Here we have simpler settings. We'll leave the options to display a hatched piping section with hatch walls only set. Now go to the Display tab and change the view direction to Profile. Turn on outside pipe walls. Turn off pipe end line. And turn on pipe hatch. Set the color of the pipe hatch to blue. In the Component Hatch display, change the pipe hatch to Solid Fill. Now change the view direction to Section. Turn on Crossing Pipes Inside Wall, Crossing Pipe Outside Wall, and Crossing Pipe Hatch and turn off Sliced Solid Pipe Walls. Set the color of the crossing pipe hatch to blue. Click OK to save the style and review the changes. We now have some clear stars that we can use for our documentation. In the next part of this video, we'll edit and alley pipe and structure label styles.